Okay, everybody, welcome back. All right, let's see how many of you guys I get today. Let's see. Abby.
Here.
All right. Laura.
Here.
Okay, Deirdre.
Here.
Ashley.
Here.
Paulina.
Here.
Akili. Liam.
Here.
Emily.
Here.
Mara. Savannah.
Here.
Okay. Carrie.
Here.
James Lynn. Amanda. No, okay. Steffi.
Hi, I'm here.
Hello, hello. Christina.
Well, I'm here.
Hello, hello. Naja.
Here.
Okay. Morgan. Gianna.
Here.
Okay. Apurva.
Yeah.
Great. Samantha.
Here.
Nice. Jenny.
Here.
Okay. Joy.
Here.
And Alexis.
Here.
Okay. Last call for Morgan. Amanda. James Lynn. Oh, Mara, you're here. I see you. You're here. And Akili. Right? Okay. So I'm missing Akili, James Lynn. I do see Amanda logging in right now. Saved by the Zoom. Okay, I think that's it. All right, so let me know if Morgan, James Lynn, and Akili show up, okay? All right, guys, so I know people have been asking, like, do we have class on Wednesday? I'm like, yes, it's a Wednesday. But I purposely planned today's class so it'll be very short. So let's try to go for that. And so we can all start our Thanksgiving a little bit early. If you don't celebrate it, you can start your holidays early, right? As in, it's a long weekend, right? Thursday, Friday, Saturday, Sunday. Very nice. Okay. Let's see. So let's start with some reviews, right? What did we do? You guys are my Monday, Wednesday. So Monday and the week before, what did we been talking about, guys?
Hypothesis testing.
Yes, we have. Thank you, Christina. We have been talking about hypothesis testing. So let's talk about what we're kind of doing, what we're doing hypothesis testing for, kind of like in an abstract way. And then let's talk about kind of in detail what those steps look like. What is hypothesis testing? What is our overarching goal, guys, with hypothesis testing?
To reject the null hypothesis.
To reject the null hypothesis, that's correct, right? So we actually have kind of like something in mind, like a claim that we want to make, but we need to basically, in any scientific community, you want to be able to kind of prove that. Proving something that is always true is a very difficult thing to do. So usually what we do is we set up something called a null hypothesis, for example, and we find an example that would counteract that null so that we can reject it, which will eventually help us kind of accept the claim that we were making. Okay, so good. But let's take it a step back. Why are we even doing this? Why are we setting up a null? Why are we making an alternative hypothesis? And why are we going through all these steps? What are we trying to really do?
We're assessing a claim about a population.
Very good. Excellent. If you have noticed anything in this entire semester, what we're always trying to do is to make some scholarly, educated guesses about the population parameter. right? That population parameter, that population metric could be the population mean, the population standard deviation, the population variance, whatever it may be, or a combination of those. We don't know what it is, right? We don't have information about the population. So through series of steps, or whatever method it may be, we are trying to guess, make an educated scholarly guess about what the population parameters would look like. Okay, very good, Samantha, right? So that's the kind of big overarching goal. And in order to do that, one of the methods we've learned many, many methods to do that. One of the methods, just in many, many methods that exist in statistics, one of the things we're doing is hypothesis testing. And as Christina pointed out, we will set up a null hypothesis and an alternative hypothesis, really wanting to support the claim of the alternative hypothesis, kind of like in a roundabout way, if you will, by rejecting the null hypothesis. Okay, good. So what else? How do we then go about really doing that? So that's the very beginning step of hypothesis testing. What other steps do we go through?
Taking a random sample.
What about a random sample? I kind of missed the first part.
I said taking a random sample. So like the step 2 where you find T.
Very good, right? So we will usually go about, because you've got to start somewhere. So usually in that, what that means is we'll take a sample that represents the population. Hopefully it's a random sample, so it's not like a very biased sample, so that we can draw conclusions from that sample, okay? It is possible that you will actually be given the raw data of the sample, like we did in the MBA problem last week, or you just get the summary statistics of that sample, right? You get the mean of that sample and maybe the standard deviation of that sample, okay? Whichever way it is, even if you start with the raw data, you should be able to calculate the sample mean and sample standard deviation, so you're good to go, okay? So we set the null, we set the alternative, and then we take a look at our sample data. Okay, good. Then what do we do, guys?
Find the p-value.
Right before that, so that's kind of like going to the next step, which is good, but we need to do one more thing before we get to the p-value.
Compute the t-score.
Very good. Okay, so depending on your given information, you will be calculating some kind of critical value. The ones that we've been dealing with most of the time have been the t critical value. In the t distribution. That's when we only have the sample standard deviation available, right? If for some reason, which is not likely to happen in real life, if for some reason you have sigma, which is the population standard deviation, then we will use the z critical value. Whichever one it is, you will use the appropriate equation, plug it in, and then eventually we will get the p-value. In other words, the area under the curve. And because it is area under the curve, the p-value will always be between 0 and 1. Okay? So then we did calculate the p-value. So what? What do we do with that p-value, guys?
Make a conclusion.
Very good. Yes, indeed. We make a conclusion. So what are the possible conclusions we can make, guys? It goes into 2 categories.
Reject or accept the null.
So we either reject the null or fail to reject the null, right?
Or failed, yeah.
We don't really use the terminology of accepting the null. We just say reject or fail to reject, right? So if you reject the null, and that could be done in kind of a few variations, right? We can like strongly reject it, we can just reject, we can moderately reject it, and that can be, those are the nuances that you can refer to the table to figure out. But in all of those kind of go under the domain of rejecting the null, which is where we want to go. And then the least ideal situation is that we just don't have enough to reject the null, so we fail to reject the null hypothesis. Very good. And then the conclusion can be further contextualize in the problem set we were doing, right? For example, the NBA problem, we reject the null hypothesis, meaning that after the rules have changed, we do see an increase in scores among the NBA players, things like that. Okay, So that will be our case. I think somebody asked an excellent question of like, well, what do you do if you fail to reject the null hypothesis? Then that will depend on the researcher's next goal, right? Do you have unlimited funding and resources to do the experiment again and maybe get another sample, a larger sample or more random sample and experiment, repeat that experiment instead of 10 times, like 20 times, 30 times, 100 times, then you might keep going. Or maybe you kind of revisit your questions and maybe you set a new null hypothesis and a new alternative hypothesis and do something new, right? If it's a drug company, maybe if you're really not confident that this drug that you created is going to do what it's aiming to do, then you go back into developing a new drug or modify the drug that you developed and then do a null hypothesis when the new drug is available, right? Depending on whatever the situation is, you will do that and then re-enter the whole area of hypothesis testing. So you can maybe draw conclusions that are actually fitting for your research purpose. Okay, so Morgan, I got you. So you're here. By any chance, did James Lynn and Akili come? No? Okay. All right, so let's move on. So you have come a long way, ladies and gentlemen, and I would like to congratulate you because now we are at our final topic of the semester. This will be kind of like the official final topic, and then as kind of like some side things, I have prepared the misuse of statistics lecture and a data visualization lecture, which will be a lot of doing interactive stuff. So hopefully we can have time for that, but that's like additional stuff that are created for you guys in case we have extra time. But the focus will be completing this last topic, which is called regression, and then making sure that we have plenty of time for final reviews. Remember that the final exam is a cumulative. So this starts from all the way from the beginning where we defined a population parameter and then sample statistic, inferential statistics, and all of that stuff, all the way up to today's topic, which will last a few sessions, called regression. Okay, so it's a cumulative that's coming. Let me get my calendar. One of the few things I still do on paper. So for you guys are Monday class. So your last day of class is quite late because you had some holidays. And in my calendar, and I believe this is aligned with the FIT calendar, your last day of class is December 21st. Do I have that right? So that is,
Yes.
Yeah, okay. So that is the day you will take the final exam for this course. Okay, so I'm definitely, that means December 16th, I'm dedicating the entire class time for a review for the final. And maybe if there is a need and you guys want it, we can use another day, like the 14th of December, to review for the final as well. That is up to you guys. But other than that, today is the 25th. So the 25th and 30th and December 2nd should be dedicated to the topic of regression. So we'll complete that. And hopefully I can do a lecture on the misuses of statistics and data visualization. And I think that will still give us enough time to do plenty of review for the final. Okay, any questions on that timeline? Just to kind of give you an idea. The end of the semester is coming, guys, believe it or not. The end of the year of 2020 is also coming. Ah. Okay, so just keep that in mind. All right, so let's get to it. Regression, guys. So what today we're gonna do is we're gonna actually go to Mathplosion and read the chapter together to understand the basic concepts of regression. It's gonna be quite straightforward because it relates to a lot of stuff that you did in high school, mainly y equals mx plus b. Basically, if you know what that means, pretty much you will understand regression pretty well. So it won't be too much of a difficult topic in my opinion. It's one of my favorite topics too. And it's a topic that I actually go into detail a lot in my machine learning / stats course in the 322, the upper level of this course, okay? So we'll go through that together. And then And then we'll go into Google spreadsheet and do things together, like using the tools to draw like scatter plots and whatnot together. And then I'm just going to end the class there. We should be able to get out at least 30 minutes early. That's my goal. Okay. So let's see if we get there. Okay. So let's all go to, in your Blackboard, go to content and then go to regression. That should be one of the last folders in content. And that should appear now if it didn't yesterday. Oh, I think it was there yesterday too. Anyways. So go to regression. Oh my gosh, guys. So I'm going to do a Friendsgiving tomorrow. And apparently Popeyes was doing this thing where they do a deep fried turkey. And my friend's like, let's get it. And I was like, ew. And they're like, no, we got to do this, right? For $39.99. And I was like, oh my God. And then my friends are lazy. So they called today. And guess what happened? They're sold out. Oh, so they can't even get it. They're like, this is such a bummer. I'm like, oh my God, thank God. But then they were like, just in case, like we can't really eat it because it is actually disgusting. Why don't you cook a main dish too? I'm like, you guys just want to waste. Anyways, they can't waste money on it because they can't even get it. Who would have thought deep fried turkey would be that popular, guys? It's kind of like a soul food flair on it or something. How do you even fry it? Oh, I guess they have these big frying things, right? Like a whole turkey, deep fry that entire. Oh, and guess what I heard? Is this true? Do any of you guys know? Progressive Insurance like teamed up with Whole Foods or something because they know like a lot of people are not going home. So there's going to be first time chefs, basically amateur chefs trying to like, do a turkey dish. They're going to burn their turkey. So apparently there's an insurance you can get at Whole Foods. So in case your turkey burns, you get like a new turkey or something. Somebody told me and I was like, I thought sounds kind of like a joke.
That's honestly so smart.
I know, like if you only charge, let's say $1, people might be like, okay. And then you just need, I don't know, 10,000 people. Anyways, the fire department apparently is getting ready. They're like, there's going to be so many fires this Thanksgiving.
Well, the hospitals usually get ready too, because I know like so many people like get so sick on Thanksgiving, or like people like are close to having like heart attacks or whatever, that they go to the hospital. So like,
because you eat deep fried turkey. Why would you do that to yourself? Oh, this new Popeyes that opened up in Harlem near my place. It's like there's a deep fried turkey, selling Popeyes, and right next to it is a Krispy Kreme. You have those every day, you are guaranteed to die from a heart attack. It's delicious, don't get me wrong, but gotta like modify, I gotta like have some self-control, which I don't, so I can't judge. But anyways, oh my God, I thought we were gonna have deep fried turkey tomorrow. I was like, oh my God. Given that I can't control myself, that would have been a disaster. We need to stop eating as much. Again, I cannot judge because I overeat all the time, but I don't know. Why do you think this is a culture where we just cook too many things on Thanksgiving? I'm saying this as I'm preparing like 6 different dishes. I don't know. I don't know why this is a thing, but this is a thing apparently, guys. Okay. So what you're going to do in Blackboard in regression, the very top one is going to say simple regression. It's going to be a link, and that should open up to Mathplosion. Okay, that should be chapter 25 for now. And I'm not going to get any new chapters in. This semester's just been crazy, but I will eventually. That's what the holiday is for. I fry my turkey. Carrie fries her turkey. I mean, if you do it well, I can definitely think how it could be very tasty. Some people order like a week in advance, anything fried. You know what you guys should, I didn't even know this word. Smoked Cornish hens. We did that one year instead of a turkey for Thanksgiving. Oh, guys, it's so good. It's like unreal, out of this world, guys. Air fried turkey sounds like a great idea. Oh, maybe I should try that. I do have an air fryer. It's like, that's like the thing now, you know what I mean? Oh, but in general, I'm not very much of a turkey person. I don't know. I haven't heard a lot of situations where I'm like, turkey's so delicious. I feel like, I don't know. Maybe I just haven't I don't have like a lot of friends who like cook well.
Turkey is also just like drier in general. so
Right?
most people
That's
don't really
scam.
like turkey.
It's a scam.
Like
This
what?
is the only time people will ever buy turkey.
Yeah, pretty much.
Oh, the turkey farmers are so angry because like all these big families are not getting together, so everybody wants a small turkey. So they're all like, I didn't know I had to put my turkeys on a diet. So all the smaller turkeys are all sold out, and all these big turkeys are just like just there. Oh, if you air fry, it's so dry. Huh. Interesting. That's
That's
why
why you eat it with all the gravy on top, like extra gravy, like just mixed,
gravy.
you know.
Oh, I'm getting hungry. Oh boy. Okay. Well, anyways, if you have chapter 25 open on Mathplosion and you see something like my screen, please type Mathplosion in the chat. Let's see if you guys know how to even spell that. Not that it's an important word. I feel like we've gone through this semester and some of you guys don't even know what Mathplosion is. That's the name of our textbook, kind of. That's the service we use to publish our textbook for free. Let's see. Yay! Oh, people know how to spell it. That's good. Nice. It's exploding with exciting math. I think that's the idea, guys. Okay. Simple regression, guys. Regression is probably, in my mind, one of the most important topics. It's very widely used, and it's a very important concept. So let's get at it. Okay. Let's start with the first two paragraphs. Steffi, can you get us started?
Yes, hold on. Let me pull it back up. I was looking at your screen. Oh, there it is. Okay. To understand regression, we have to look at the data and think about if there's some kind of trend to it. For example, the data increasing, trending uphill, or decreasing, trending downhill. If it is, then we may be able to use this trend to try to predict what the data is doing. Here is an example of some sales data for some product over several years.
Okay, so this is just some fake data that we put in there. And let's pretend that this is in thousands of dollars. So year one, 45 means that $45,000 worth of stuff have been sold. Okay, so you can imagine, maybe you can put it in a context of a fashion startup or maybe, and then they just started 5 years ago. The first year they had $45,000 worth of sales, and it looks like 56, 58, 50, it looks like it's kind of trending uphill, right? From the small data points we have. Okay, so next one, Samantha.
Can we use this data to predict what the sales will be for the product for the next few years? Say we want to try to predict it for year 6 and year 7, which are in the future.
Okay, so this word, guys, predict. This is all the rage right now. So in computer science, in my field, you've heard of AI, you might have heard of machine learning. The common theme centered around those technologies is prediction. And it's all about the prediction because everybody wants to make a prediction. They want to predict what the sales forecast would be next year. Well, we want to see what the consumers will be buying next season or whatever. All these prediction recommendation systems. What's a good example for that? Stitch Fix. They want to be able to predict what you're going to keep next time in terms of the fashion style that was delivered to you. All about the prediction. Why? Because prediction is equal to capital. In capital, in a capitalistic society, everybody's trying to make profit. So this is why AI and machine learning is so hot right now, and everybody's talking about it, and there's so much money in it because it allows us to predict. And why is it so big now? Because it's not a new concept. It's so big now because unlike before, and this is merely like even 7-8 years ago, we were not at a point where we collected this amount of data. Right? We have your Apple Watch and a Fitbit, you have your smartphones, your desktop, your tablets, and just like every single thing you do, when you breathe and breathe out, Alexa, everything is collecting data to just a gross amount of effect. Meaning with all that data, you can make better predictions and possibly more accurate predictions. And where prediction lies, money lies. So this is why it's so big, okay? In regression, it's a very old concept, but it's used a lot in machine learning to do that exactly. Okay, so we're going to do on a smaller scale. We're going to try and make some predictions. Okay, so the first thing you might want to do is with whatever data set you have, you want to like plot it. Okay, and I think we might have talked about scatter plot very briefly. If not, well, now you know. Literally, the data points are scattered around, and you will kind of know this is just like a typical graph that you are familiar with from high school with an x-axis and a y-axis. Okay. Savannah, can you read this for us?
This is called a scatter plot. A scatter plot is where you display the x and y for each of the data points we have. This is just the familiar plot of x, y points in the plane that you knew from high school.
Right, so just plotting it, for, one point might be 1 and 45, et cetera, et cetera. You're just plotting it. That's a scatter plot for you, right? Each x value has a corresponding y value, right? When you plug in x, you get y as a result. Y equals mx plus b. Okay, so next one, Deidre.
So maybe we can use the x value to predict the y value. If the data is not too scattered, then this makes sense. In this case, the scatter is not too broad. In order to do this, we have to come up with a way of modeling the data. In our case, we will model this relationship between x and y by using a straight line.
Okay, what's so funny? Okay, so I do need to see it should be not too broad. There's a spelling error there. Okay, yeah, so we are going to come with a way to model the data. So this is actually a technical terminology we do use. We're going to model the data, meaning that we're going to find this trending line, this regression line, as we're going to call it. Okay, so we will go ahead and model this relationship. We're going to define. Modeling also means defining this relationship between the x's and y's. Okay, so the next one says modeling the data with a straight line. Next to paragraphs, Gianna.
First, we need a model for what is happening. Suppose we try to model the relationship between x and y with a straight line. It looks like it is trending up more or less in a line, though maybe not a perfect line.
Right? Okay, so this is where regression comes in, guys, okay? So if you were talking about your high school y equals mx plus b, this is not what you will be looking at. What you will be looking at is this first dot should be on top of that line, that dot should be on top of that line, this dot should be on top of that line, and it should every single data point should be on that line, okay? That's the y equals mx plus b. However, this particular model, we can call it a model, or this particular line, or to be more specific, this regression line is what we're dealing with here. And it's a basically kind of like an average line, if you were kind of like really simplistic about it, a trend line. Yes, Morgan. So what we're going to do in Google spreadsheet, it's going to be called a trend line, and we're going to tick that box off, and it's going to like draw that line for you. So we can call it a trend line as well. Okay, so that's the model we're looking for. And the point is that it's trying to represent all the data the best way it can. Another way of calling it, we call it the best fitted line, right? It's trying to fit all the data in the best possible way, quote unquote, by averaging them. We don't actually average them the way we know the definition of average, but it's kind of going through a similar process to average all the data points to find a representative line. Okay, so that's kind of like the rough idea you can have. And what's great about this is that based on these past data, we have drawn this trend line, if you will. What that allows you to do is now you can plug in a new data point, a new X value, which will give you a corresponding Y value. And that will be your prediction. And that's what we're trying to do today. Okay, all right. So these two, Jenny, please.
We will see a little later where the straight line comes from. It's called the regression line. But for right now, just notice that this straight line fits the data pretty well, but the data is not a perfect fit and has some scatter. How can we use this straight line to predict the sales using the year?
right? So we're going to be able to predict the sales, which is the Y variable, so the dependent variable, by using year, the independent variable. So in other words, the X variable. So we're predicting the Y from the X, predicting the dependent from the independent. Okay, so these kind of terminologies might be coming back to you as we're reviewing them. Okay, so doing predictions of Y from X using the graph. Okay, so these two, let's see, Emily, please.
Basically, we can predict the sales by going to the year we are interested in and going up to the line and taking that value as our prediction of the sales. More or less, we are just extending the trend we see from the line.
Right, we're extending the trend we see from the line. So we will type plug in 6 in our X, and then we will find our prediction for that year, and then we'll do the same for 7, and you can keep going. Okay, making predictions using the equation of a line. So now, in particular, we actually have to come with that equation, like as in we have to calculate the slope and the y-intercept and all of that, and actually come up with that regression line. And so that will be the next step to do. Next one, Joy, please.
This turns out that what we just described can be done with the straight line equation as well. So doing predictions will amount to plugging an X value in and getting Y value out. So we say we are predicting Y values from X values.
Excellent, right? We are predicting Y values from the X value. So based on the 4 or 5 data points that were given to us, you will be able to calculate the slope, which you might remember that we denote as M. And then we will be able to also calculate the y-intercept, which we denoted as B, y equals mx plus b. And then you would have the equation, right? You will have that model available to you. And then it's the last thing you just need to do is that you plug in. You plug in the X, and then you calculate the Y, as in you find the prediction for that particular independent variable X. Okay, so, if you wanted to actually follow through, you can type in, plug in the 6, and then as a result, you'll get 77. So in year 6, based on the past data, we predict that we will have about $77,000 worth of sales. Based on the past data, in year 7, we believe we will have about $83,200 worth of sale. Okay, so this is what we're predicting. This is a very simplified version. You definitely want to be able to draw a regression line with more than 5 points to begin with. But this is just, to cover the theoretical concept. So we'll start with 5 or 4 points or something. But usually you'll have a lot more than that, right? If you were just thinking about sales transaction of Amazon or H&M or Zara, it's going to be definitely way more than this, right? So it'll be easier to maybe find a regression line. And when I say easier, the computer will compute all of this, but it will have more rich information so that maybe your prediction can be better. Some of the things that will get in the way would be some unpredictable variables, right? Such as COVID-19, right? Nobody saw, well, some people saw it, but anyways, it was kind of like a pretty big shock and surprise for a lot of retail companies, right? And so this is kind of like a variable that was not considered before, which is now affecting the sales in many different ways, right? So these could be like additional variables. This is what we're doing right now. If you paid attention, it's called simple regression, meaning that we call it, to be more technical, it's called a simple linear regression because we only have one X variable. We probably won't have time in this class to go further, but there is something called multiple linear regression, and that's when there's more than one X, right? There's one variable and another variable and a third variable, et cetera, right? And if you think about real world sales data, for example, let's just go with H&M's data, you can imagine it's not only going to be one thing that affects their sales, right? Something like COVID-19 could be a variable, right? Their online presence can be a variable. Their promotions could be a variable. Seasonality will be a variable. Weather will be a variable. Celebrity endorsement may be a variable. The trending color of that season or whatever. All of these things could be different variables, right? And that can affect your prediction. So usually in real life, we would do multiple linear regression, but just keep that in mind. But today, and probably for this course, we'll only stick to simple linear regression, which means that there's only one X variable, so one independent variable, and we have one prediction, okay? Usually there should be a lot of independent variables for one prediction, but we probably won't get to that in this class, okay? All right, so this is kind of how you can predict the sales for year 6 and maybe year 7. Okay, interestingly enough, after you have drawn the line, the trend line, or you have created the regression line with y equals mx plus b, you can actually go back to the past, right? So you have the actual sales from like year 4, but you could use the equation that you calculated and actually plug in forward to see what was expected. If you were dependent on this particular regression line, well, this is what it predicted. It predicted that you would have made about $64,600 in sales, right? Well, is that correct? Well, no, actually. What we see in our data set is that actually $58,000 worth of sales were made, right? So if you actually subtracted then you would see basically the error in your prediction, okay? And this is not uncommon. If you think about it, prediction at the end of the day is just a prediction, right? It's a scholarly, maybe educated guess, but it's still a guess, meaning that it is prone to errors, and that's going to happen a lot. What these big companies' goal is to reduce that error as much as possible, right? I am learning. I am learning from you guys, actually, especially from FBM students, because they do a lot of inventory and retail. Hold on a second. I know that this predicting how much sales there would be is actually very, very important. In terms of inventory, I heard, and you guys might know this, or you guys will eventually learn this, ordering more than you will actually sell is a huge loss for the company, but also under ordering and not having the items available when customers are looking for it is also apparently a very, very big mistake you will be making in inventory. Apparently you might think one is worse than the other, but apparently they're equally really, really bad in terms of obviously making profit for the company. So those kind of sales predictions would be super, super helpful if it was more accurate, right? $6,600, just by looking at it might not seem like a lot, but if you think about big companies like H&M and Zara and whatnot, they're like just a little, like a 1% margin of error could really mean millions of dollars for them. So that would be ideal for them to be able to predict more accurately. And unfortunately, this class doesn't exist anymore, but I was sitting in a predictive analytics course a few semesters ago. This was, hopefully they bring it back. It's just FIT like being financially constrained and can't really afford it anymore. But we had a professor from FBM and a professor from our department, Calvin, would come together. And so the FBM professor had just amazing knowledge about inventory and retail and all that. So he brought in that perspective. And then Calvin in our math department brought in all the forecasting and regression and math components. So they taught that together. So it was a beautiful math class that was geared toward like FBM majors, for example. And so they did a lot of sales forecasting and stuff. One of the lectures that they did, which I really loved, was they invited somebody from a company called Planalytics. I don't know if you've heard about it, but it's fascinating because that company, it's kind of like a consulting company, if you will. And what they do is that they analyze weather data. That's all they do. And all their clients are like really big, like Dunkin' Donuts or H&M and all these different things. And what they do is that they take the take the company's data from the past and analyze everything that would have happened because of some kind of weather change. And so they say based on that, in like next year in January with this kind of weather prediction, these are the things that we recommend that you do, or you should be thinking about in terms of stocking the inventory and et cetera, et cetera. So they're solely focused on one variable, which is weather, right? And apparently this makes a huge difference in sales. And you can imagine, right? For certain items, it's so obvious, right? Like swimwear or like scarves and hats and stuff. Those are super obvious that the weather will really depend, weather will really affect it. But some other places where you might have not really kind of guessed, apparently weather has a huge influence on sales. So that kind of information, so basically these clients, these companies like Dunkin' Donuts go to them, pay money and say, hey, here's our data. I want you to analyze it and tell us what our next move should be, right? So this happens a lot. So you can imagine weather data has such a big influence. Then all these different things would have even more like influence, maybe the social media presence, maybe whether it's fashion week or not, something's featured somewhere, a celebrity endorsed it, you know, a big thing these days is sustainability and stuff. Like maybe if it was a leak that they don't use sustainable material, or they're like very abusive in these like third world countries where all these t-shirts are made or something like that, and that gives a bad image of the company. Like all these different things will affect the sales, right? So to be able to make that prediction as accurately as possible, that's where the gold mine is. That's why AI and machine learning is so huge, because you might pay a consulting company a hefty price, but if they can give you a really good prediction and really shrink your error and all this inventory stuff, then you are saving billions and millions of dollars, right? So that's why this is kind of like very big right now. Okay, what was the class called again? It was called Predictive Analytics. I believe that was the full class title. And it was an MA, I think it's something like 329 was the name of it. And Gary Wolf from FBM and Calvin Williamson from math were teaching it together. One of the things, you guys a lot of you guys are new to FIT, but you might not see a lot of cases where two professors teach one course. And we had a contract with the union to do that. But you know, it does cost twice as more because it's two professors teaching one course. So basically, financially, it wasn't the best model, even though I thought that class was taught beautifully together. It was featured on Wall Street Journal too, as this beautiful course that was taught. Our professor, Calvin, was like, oh, it was in this issue. And like right before my article was like, Natalie Portman was on it. This is like my biggest famed moment. And he was showing me when I started it. Like, it was so cute. He's amazing. He's like, this is my highlight. This is like the peak of my career. And I was like, oh, he's done amazing things other than that, but he like kind of jokes about that. So there aren't gonna be any more two professor courses. Like I was kind of planning on doing that too, to bring the math and computer science into like a more fashion oriented course. That seems to be a little bit of a challenge moving forward, because somebody like who was negotiating on behalf of us wasn't able to negotiate it. So all of those classes are not going to run. If there's a class that did not run 3 times with 2 professors, they can still do it up to 3 times. But this class was so popular, I think it ran 6 or 8 times. And so after that, like, it can't run anymore. But you guys should like request it so it can come back or something. Anyways, so I'm gonna try to find funding opportunities so we can teach more classes like that. So we'll see. It does seem like there's a lot of money into integrating math and computer science and STEM and all of that into non-STEM areas. So it's a good there's opportunities. So we'll see if we can find some money to do that. But anyways, but you know, things like this are happening, and regression in that regard is like a very good model to use to make sales forecasts, for example. Okay. All right. So I think the last bit of this chapter is, so, you know, as we were just talking about, models are not always perfect. And you do have to kind of worry about how big the error will be. And our goal is to try to reduce that error as much as possible. Okay, so interpretation of the slope of the model. Okay, let's see. Can you read this, Laura, please?
One good way to explain a model that uses a straight line in plain English is to give the interpretation of the slope from the equation being used. In this case, based on the interpretation of slope for straight lines, we can say for each additional year, the sale increases by 6.2 units of Y.
Very good, right? Can you just go ahead and do the rest of it too?
Yeah, or we can say this a little better this way. For each year, we expect an average sales increases by 6,200 units of Y.
Very good, right? So, you know, because this is in the thousands of units, if you wanted to kind of fully contextualize it, it's worth about $6,200 worth of units. And that we expect to increase based on this particular regression line. Okay, all right, so where does this regression equation come from? As I said before, we won't be doing it by hand. This was done by hand a lot in more traditional stats courses, which this one is a traditional course too, if you will, but you know, we like to use what's available to us, so we're gonna do that in Google, okay? Google spreadsheet, I mean. All right, so that was that. Okay, very good. So that's the chapter 25. And then now let's do it by hand ourselves. Okay, so we're gonna do some in-class activity. So go ahead and go back to Blackboard and content, and inside regression, I believe it's the second one, and it says in-class activity Google spreadsheet. So go ahead and open that. Make sure that you make a copy for yourself, and we're gonna be doing this together, and then you're gonna share this with me at the end of it so you can get all the class participation grade, okay? Once you have opened that up and you made a copy for yourself and you're ready to kind of do the equations, type in spreadsheet in the chat. Okay, and then I'll know how many of you guys are ready, and I'll get that open too, and I'll zoom in so you guys can see better. But you should see something similar to what was in the textbook with year 1, 2, 3, 4 and sales and a few things. All right, quite a bit of spreadsheet. So we're getting ready. Okay, so it should be titled something like regression, slope, and intercept. All right, so let me share my screen. Okay, so let's see. So look at this. So this is the data that's available, and it's only 4 points, so it's a very small data set, but we're just gonna go with it because that's what we have for now, just for practice purposes, okay? Here I wrote M and wrote B, and N, remember, is the symbol we use for slope. So if you want to add that, you can do that. And B, if you remember, is the slope we use for Y intercept. So if you want to include that in there, you can do that, okay? So how do we do the M? Well, what are we going to do? I'm going to do it right next to that, right? So that's kind of like the name for it. And then I'm going to actually do it here. You're going to do equal, and literally the function is a slope, okay? Open the parentheses. So you want to start with the Y inputs first and then the X inputs. So you're going to select starting from 53 and kind of that whole range. So then automatically it would do something like B2 all the way to B5, and then comma. So that's the Y part. And then you're going to select the Y area. That's going to be something like A2 all the way to A5. Make sure you close the parentheses. Always when you open one, you have to close it, okay? So you're going to hit enter. And then you have the slope like that, right? So that's what we mean by we're not going to do it all by hand, but we are going to let spreadsheet take care of that for us, okay?
Wait, Professor, what was it? It was slope, and then it was B.
Yep.
The B column and then the A column?
Yep. So you want to start with the Y numbers, then comma, and then the x's.
Oh, okay.
Yep.
Okay, thank you.
Yep, and that's gonna be the exact same order that you're gonna keep for the y-intercept as well. Okay, so go ahead and do equal, and it's literally intercept, and you probably don't even have to finish it because once you get to enter, that's the only option that's gonna pop up. And then again, choose the y stuff first, and all of that whole range of 4 cells, and then comma, and all of the year stuff too. Close your parentheses and hit enter. So you should see something like that. And if you were to write out the equation, you can go ahead and do that, right? You can do y equals, m is up here, so 1.7 times x plus the y-intercept, which is 51.5. Okay, so if you want to write it out, you can write it out like that. Y equals mx plus b. You would see, you will see that there's a little bit of a difference, or a difference as in like I put equation here, and then you might see right underneath that I have regression model. So this is because this is y equals mx plus b, right? However, when you're dealing with the regression model, actually it's slightly different from y equals mx plus b, okay? And what I mean by that is, let me see, did I close that out? Okay, I didn't mean to close it out, but let me just show you. So what the difference that you need to know between the usual y equals mx plus b is, let's give you, we'll get to the r squared eventually. This is going to be the difference. It's kind of like the left graph versus the right graph, okay? So y equals mx plus b is going to look something like this. So let's pretend like I drew this line through all these data points, right? Y equals mx plus b from your recollection will be that every single point is on top of the line. Okay, that's y equals mx plus b. But remember, this regression line is a best fitted line. So it's gonna go through these points, but the data points are not gonna be exactly on top of that line. This line in particular is a prediction line, right? So it's not a straight line where it's every single data point lies on top of the line. That's not what we're dealing with when we do a regression line. So technically, there should be a little bit of a difference, and that's why I put this regression model cell right here. So technically what happens is that you might remember from your calculator, there's like this little thing called a caret. And you use that when you do squared something, right? So that also is called a hat. And usually on top of this y, you would put that caret and we call it y hat. So technically, and I don't know how to put that caret on top of y inside Google spreadsheet. So I'll just write it out like y hat. So when you see something like y hat equals, and even though it's basically the same thing in regression models, when you write the equation out, we like to put the b first. So we like to put the intercept first, and then we do 1.7 times x. So the usual equation is y hat, if that symbol existed, and it would be kind of like beta plus, and then we use some kind of different symbol, but I'll just call it mx. Okay, and basically for practical purposes, it's exactly the same, right? This number, the m and b are not going to change, but we denote it a little bit differently so that we have that distinction, because technically they are two different things. Okay, the thing you have to remember is that when we are dealing with regression, look at this, right? The data does not exactly lie on top of the line because it's a prediction line. So it's not going to be exactly what you think of when you think of y equals mx plus b. But for practical purposes, when you like calculate anything, this is eventually going to be the same thing. Okay, so I just put that in there so there's a little bit of a distinction, okay? But at the end of the day, it's basically y equals mx plus b. All right, so we have all of this, we have the M and the B, and we can write it out either in this format or that format. Either format I will accept, don't worry about it. All you need to know is that you need to know that the M is multiplied by the X, right? And then you have the intercept kind of alone there. Okay, so that was great. This is all the past data, and we calculated all of that. We can even write out the equation. That's all great. Okay, but now really is the important part. We want to make some predictions, right? Specifically, we want to make predictions for year 5, 6, and 7, and 8, okay? So this is how we're going to do it. This is a while ago when we did this, but you might remember we would do something and then we drag, from this little square on the bottom right, we will drag it down and apply that to everything. So, but sometimes we needed to make sure that every time you drag it down, like the number doesn't change, and we anchored it with a dollar sign. You might or might not remember that. It's okay if you don't, but what we're gonna do is we're gonna use that anchor dollar sign again to anchor it. So what that means is that I'm gonna do equal. And what I am is going to do, I basically want to include 5 inside my X. I want to input that number in 5, and then I want to calculate what the Y is. In order to do that, I could just do 1.7 times 5, but what I'm going to do instead is I'm going to do the 5 like this, dollar sign, and this is D9 right now. So I'm going to do D, and then I'm going to do dollar sign and 9. So then it will immediately recognize it's this one. Okay, so this basically is kind of guaranteeing that it's always 5 that's going to be inputted, and it won't like be replaced by 6, 7, or 8 or something like that. Okay, so that's my X input, and then I'm going to do the asterisk to do times, and 1.7 is our slope, right? So I'm going to click on that cell. So it's X times the slope plus my intercept. Okay. So that's going to be my prediction for year 5. And I hit enter. It thinks that it's going to be about $60,000 worth of sale. Okay. Try that again with number 6, year 6. You're going to do equal again. Remember that dollar sign. And then it's the cell is D10. So dollar sign 10. And then it's going to recognize it and it's going to highlight it because now it realizes what I'm doing. I'm going to multiply that by the slope again, and then I'm going to do plus intercept. Okay, and then hit enter. Okay, great. You guys do 7 and 8 on your own and trying repeating that. I'll click on this so you see that. You want to anchor the cell that we're referring to as our X, and then you multiply it by the slope, and then you add the y-intercept. Get the chat open.
Professor, don't you want to anchor the M and the B? That way you can drag it down.
The M and the B
don't anchor the X.
The M and the B is never going to change, right? It's when you click on this one, it's always going to be that same.
Right, that's why you anchor it.
It's you only need anchoring when I guess in our old example, we wanted to always use that same number and it's applied to everything. So I can see why you're asking that question. In this particular case, the E2 and E3 are staying and nothing's changing. And the X is the one that we're kind of worried about. So, I mean, you don't have to do it this way. Let's see if I can just do it.
Right, but if you take the 60 and drag it down, it's not going to change. That's why I was saying you should anchor E2 and E3. That way they never change. The reference cell never changes. And then when you drag it down, the X value changes as you go down.
Oh, you know what? You might be right about that. Let me try that actually.
Because otherwise you have to type it out.
I actually think you are completely right. So this times, and then I anchor this. Oh, so let me do that. Funny. Okay, so let me try this then. Equals, can I start with the dollar sign? And then, oh, I have to do E2. Okay. E2, okay, times this. Okay, I think you're right, actually. Plus dollar sign, what is this? E3, right? Okay, and then I'm gonna do, oh, Morgan is so smart. Yes, you are correct. Oh my God. I was like not being able to figure this out on the other section. I was like, just do it manually. You're right. Guys, Morgan is your teacher now. You have to anchor the fixed ones, the M and the B, and then the one that's changing is actually the one that you can drag it down to get the answers.
Excel is really beautiful. Like, I love it. I sometimes just watch YouTube videos on it.
You are on the path of nerddom, guys. Morgan, welcome to the world. Yeah, that's amazing. Yes, absolutely. So Morgan's correct. If you want to just go ahead, and you can imagine if there was more than just 4 that you had to do, but you had to do like 20 of them, you would want to anchor it the way that Morgan was suggesting. So we anchor these 2 ones because these are the ones that we kind of hold down, if you will, right? We hold it down and we always don't change. But when we drag this down, what we're telling Excel is that, but that X number will change according to the cell right next to it. Okay, so you're absolutely right. Yes, Morgan, you are absolutely correct. And then let's hopefully, I think this is gonna be fine, but go ahead and bring this down to right here. So it can't transfers over so that we have the full data set all in one column. Beautiful, beautifully done. When you do know Excel and spreadsheet really well, it can be super, super, super fantastic. Naja was thinking the same thing. Good. Okay, I was just being the idiot apparently. Okay, so that's wonderful. And then what we're gonna do next is now we're gonna actually draw it out, okay? So I'm gonna have to zoom out just a little bit because it's gonna be way too zoomed in. Okay, so what we're gonna do is now we're gonna highlight the 2 columns. Okay, you might remember this, and I think we did do this to draw like a bar chart maybe a long time ago. So this is kind of like working really well as a review. You're gonna go to Insert, and you're gonna go into Chart. Okay, it always seems to take a second. Oh, here we go. This is why I kind of didn't want to like zoom in too much. But so I'm gonna kind of put this to the side, but you will see that you have your 1, 2, 3, 4, 5, 6, 7, 8 data points, okay? And you kind of might even be able to see a trend here, okay? So, but like, let's fix a few things, right? We just don't need all this space on the y-axis. So what you can do is usually this little editor is gonna pop up on the right side. And there's a setup part and a customize part. So go ahead and click on the customize. And what you can do is you can click on the vertical axis. And what's nice is that you can actually kind of decide what your minimum and maximum value would look like. So I kind of just don't want so much of this to be here. So maybe I say the minimum value is 35 and then the maximum value is like 75 because I just know that I don't need this much room, right? You can even make this maybe 40 to see how it changes and maybe that helps you, right? So now it's kind of in the middle and it just like, aesthetically, it's more pleasing maybe. If you don't care at all and you're not like a little OCD like I am, you don't have to do this at all. This is just for preferences, okay? So that's what I like to do. So I'm gonna do that for the vertical axis and I'm gonna do the same thing for the horizontal axis. I'm gonna like give a little bit more room on both sides. So I'm gonna say the minimum value is 0 and the maximum value is like 9 so that it's like there's a little bit of breathing room on the front and at the end of this side, okay? So that's what I'm doing. You don't have to do that again. This is just for preferences, okay? And as you can see, it's pretty self-explanatory. You can like change the axis titles and the legends and like all of that. So you can do that in your own time if you want to, okay? So the last thing we do want to do though is go to something called series. And this is where Morgan's trend line is gonna appear, or she said. And if you scroll down, there's a trend line and you can tick this box. So if you go ahead and tick it, then there is going to be that regression line that is drawn for you, okay? So you might be like, oh, this actually looks like all the data points are lining up on it. It's not true, actually. You'll see that 1 and even 2 is a little off, and 3 and 4. So these are our 4 past data inputs, right? They don't really line exactly on the regression line. However, you should be able to see that 5, 6, 7, 8, so year 5, year 6, year 7, and 8 actually do lie exactly on top of that line. Why is that, guys?
Because we use the equation to plot those predictions.
Exactly. So these ones actually are not real data that exist in this company, right? This is a prediction. And we only got that because we plugged in 5 into this line and we got the corresponding Y. So in that case, of course, 5, 6, 7, 8 will be exactly on the line. But the past data is the past data and it's scattered all over the place. So that won't really line up on that prediction line. I think I see a question that says, did we add numbers on the Y? We didn't add numbers necessarily, but I just kind of made the range from minimum to maximum. I just changed that so our view is a little bit different. So I'll show you how I did that. I'm still in customize, and I'll like collapse this. In customize, there's a lot of options. I went to vertical axis, and maybe I'll zoom in a little bit more. And I changed the minimum and maximum. So I can change this minimum to 50, and then I can change the maximum to 70, and it will kind of give you that effect of zooming in a little bit more. And now you see that how these dots are really not actually on top of the line a little bit better. So that's all I did. I didn't add anything. I just showed the minimum to maximum on this y-axis. I just change that a little bit so it looks a little bit different. And that's just a preference thing. Again, it has nothing to do with the actual accuracy or error or any of these numbers. This is just kind of like how aesthetically it looks. Okay, so that's what we did here. And so that's how you kind of can do a regression, a simple linear regression with, initially with data that's provided for you. And then from that, you can make some predictions beautifully with Morgan's help. We can do it even faster. And then you can draw your trend line like this, okay? So if you have no errors and you got all of this, you're gonna go to the upper right corner where the share button is, and you're gonna share it with me so that you can get full credit for your in-class activity today. And I'm typing in the email, Maria Huang, FIT-NYC, share that with me, and then I'll be able to check immediately if you have that. Send to me. And then you will know, not know, but also if you finish that, then let me just point out what the homework is. It's gonna be really simple. Let's see, did Akili or James Lynn come yet? No, okay, so I'm gonna close out the attendance sheet also. And I'll check my email right now to check everybody's submission. But if you have that submitted, what you should go, I'll just tell you what the homework is. Go to Blackboard. Did I close out Blackboard again? No, I did not. Good. If you go to Blackboard, and if you're still inside the regression, under content and regression, right under in-class spreadsheet activity, there's something called regression questions assignment. So go ahead and open that up. And then as usual, you're gonna only have viewing privileges. So go ahead and make a copy in your drive. And you will see that there's 3 sheets, right? Kind of like the old Google spreadsheets. And it's going to be example 1, example 2, and example 3. And it's basically exactly the same thing we did just now in class. That's what you're going to do. So those 3 questions are due next week, December 2nd at 11:59 a.m. Okay? And that's all you have to do for next week. And you can start it right now. Of course, there's no harm in like starting early. I'm going to take last minute questions before I let you guys out early today.
I have a quick question.
Yes, please.
So on the calendar, it says that there's the HT for means handout is due on the 25th, and then it also says that it's due on the 30th, and I didn't know if that was the same handout assignment or if it was two different ones.
Okay, so I'm gonna go back into content. And I'm gonna go into hypothesis testing dash means. Okay, so the HT for means handout is that Word document. Remember, we started together and we did the null and alternative. And then I said all the way at the end, there's 3 questions that are problem sets that you need to finish. And then you hand that in there, okay? And whatever deadline that says, you hand it in there. But still hand it in, okay? Like even late submission is still better than not submitting.
Okay, I was just confused because there's 2 places, like it says that it's due twice, and I didn't know which one.
Oh, you're
the correct
totally
one.
right. You're totally right.
Okay,
Okay, that's my bad. So submit it to either one of those guys. Oh, I actually did not know there was 2 of them. So either one will count. You don't have to submit it to both places, but if you want to, you can. So that's for the Word document. And then all the way at the bottom is HT for means spreadsheet. That's the spreadsheet you're gonna submit, okay?
Okay, thank you.
Okay, thanks. Yeah, thank you for clarifying that. For some reason, my line isn't straight on my graph. Okay. Next week is December, Naja, yes. I just submitted it twice. Yeah, that's fine. If you submit it twice, no problem. Okay, so Gianna, do you want to share your screen? Letting you share your screen. Okay, so if the rest of you guys are done, you have shared, let me just read out the names, so make sure that you guys all submitted it. So for you, it looks like your 5, 6, 7, 8, you got weirdly equal numbers. So you must have yeah, so it's not 51.5. That's not what you should be getting. Can you zoom in a little bit more for me so I can see what's going on? Okay, so you're not anchoring everything. The E2 and the E3 are fine, but for the D9, you're not gonna actually use it. Correct, you're gonna get rid of that. There you go. And you enter, and then go back up to that cell you were just in, and click on that square that's on the bottom right, and then drag it down to the rest. Oh.
I'm not sure what's going on.
Okay, so click on that one, D10, E2, E3, E2, yeah, what is going on? And then click on the one below that. D11. Oh, it can't be D11. It's B6, B7, B8, B9. So make sure you change that to the B, and then
You mean A. You mean A. A6.
A6. Oh, okay.
Oh, sorry, A6. Yeah. You're right.
All right. Thank you so much.
Yeah, and then you can drag it down, and it should work.
Okay.
It's beautiful. Okay.
I just have a quick question.
Yes.
So I know we're doing the questions assignment spreadsheet. Are we also doing it's a spreadsheet and there's a question assignment. So are we supposed to be doing both?
Okay, so are you talking about this week regression?
Yeah.
Okay, so right now I'm gonna call out the names. What we did in class just now, you should share that with my email. You're not submitting it on Blackboard, okay? And I have so far gotten Ashley, Joy, Naja, Liam, Amanda, Polina, Emily, Morgan, Carrie, Samantha, Deidre, Apurva, Savannah, Laura, Christina, Steffi, and Abby's one. So that's gonna count as your in-class activity participation grade today. And then the one that I just assigned you with the Google spreadsheet, which has 3 examples, 3 sheets and 3 examples, 1 example per sheet, that is gonna be what you submit on Blackboard.
Okay, so just that one thing?
Yes, just that one thing.
Okay.
Should I give you more?
No.
Gotta be careful what you say. No, I won't give you more. So that's all you got to do, guys. Have a wonderful Thanksgiving if you celebrate it. If not, just enjoy the days off, and I will see you next week.
Thank you.
Bye, thank you.
Thank you.
Thank you.
Thank you, thank you, thank you.